He studied computer science and business administration at the Technical University of Dortmund, and before joining Denodo, he held similar positions in the business intelligence and analytics environment at various American companies. Happy to have you here.
Yeah, thank you very much for the nice introduction. A warm welcome to the audience. I'm very happy that some people joining this late in the afternoon. Yes, I would like to introduce data mesh and data fabric, these two concepts, but powered by data virtualization, which means this is a more logical or virtual approach. It's not the typical physical approach you find in the market. Yes, before I step into the details of data fabric, data mesh, I would like to take a short look on different fundamental architectural patterns, which means a short look at the monolithic and a short look on distributed architectures you find today at customer side. So this is a distributed landscape we typically meet at our customers. I think this is a norm today. We have multiple different data sources on the left side. We have multiple different consumers on the right side. And the data is highly distributed. It has developed over years, over decades within the companies. And you find data in different formats, structured data, unstructured data. You find data in different locations, on-prem, of course, still a lot, but also in the cloud, in multiple cloud, in hybrid environments, in streaming devices. And you have data with different latencies. So data at rest in a database, for example, or data in motion in a Kafka queue. And very often there exists still one-to-one connection between the data consumers and the data sources, which means we have a lot of data silos. And this is a challenge and results in such a spaghetti architecture you see here on this picture. And this is challenging on one side for the IT, but also for the business side. The IT is challenged because they have to maintain this infrastructure. They have to extend this infrastructure. And if you think of kind of self-service, of development of this infrastructure, it takes a lot of time and efforts to keep it up and running. And for the consumer side, it's also challenging because the business perhaps doesn't have the data they need for their daily business. So they have to go to the IT department, and this takes time to deliver the data the consumers will need. And overall, this kind of infrastructure is not very flexible and not very agile from our point of view. So if we take a look at the monolithic architecture, all the data is stored in a centralized location, which means the IT has to set up data pipelines, very often ETL processes, multi-level ETL process. And this is also very time-consuming, cost-consuming to keep these data pipelines updated, maintained. And if you think a new system has to be integrated, the whole pipeline, the whole ETL process has to be updated. And this also takes time. And for the business users in such an infrastructure, there is no real-time access. So they are working with data maybe 1, 2 or more days older, and so the business decisions are not based on the database which are possible. And if you take a look at the Gartner quote, Gartner said that with this kind of architecture, the principle of modularity and decoupling is broken. And this is also our experience. In order to overcome these drawbacks or these challenges, we prefer a logical architecture. This is another kind of architecture where you integrate and manage data on a logical way with a semantic layer in between. So there is a decoupling of data sources with the data consumers, and it's based on two principles. One principle is that the data is left in the data system. So there is no copying of data, no replication, no ETLing of data. And the second principle is that the information is delivered and generated with a logical virtual integration technology. Sorry for this. And this kind of architecture is much more agile, business friendly, and I will explain it on the next slides why. Simple to use, and it's future proof. So the data platform between the systems and the consumers, they enable a central access to the data. And if there is a new technology to be integrated, or if you, for example, move from on-prem to a cloud infrastructure, then you have only to adapt the connectivity layer within this platform and not the whole metadata model. And this is much more agile and flexible than the monolithic architectures. So if we take a look now on data fabric and data mesh, they both belong or they're based on a distributed architecture, and the term data fabric was coined by Gartner Group to describe a distributed IT infrastructure in which the data is governed regardless of its location, if it's on-prem, if it's in cloud, if it's multiple cloud. So all these systems are integrated. You can access the data via this concept data fabric. It uses a lot of AI, ML functionality in order to generate deeper insights into the data, or in order to generate recommendations for the users. And it's overall much faster and agile than other concepts. And if we take a look on, if you take a look on a data fabric based on data virtualization, then we find such an infrastructure. On the left side, you have the different data sources. In between, you have this semantic model or the platform, data platform. On the right side, you have the data consumers. The platform is able to connect to all modern data systems. So we have, at Denodo, we have about 150 different connectors to connect to all kind of data sources. On the right side, the consumers, they have a single point of access, so they don't need to connect to every system. They only have to connect to the data platform. And the data platform logically integrates, manages, and distributes the data, and is running on all environments, which means a lot of our customers use it still on-prem, but it's also possible to use such a platform in a cloud, in a multi-cloud, or on a containerized infrastructure. And this platform comes with a lot of features or components. Very important component is the data catalog. So this is an active data catalog. When you model the semantic model, this catalog is automatically filled with metadata. So you have information on the tables, on the attributes, you have usage information, you have data quality information automatically generated within the data catalog. And there's additional the possibility for example, for a data steward to add tags, attributes to this data catalog, and the data catalog then can be used as a self-service for the business. So it's a kind of Google search. So you insert a term, and the data catalog then reveals all hits, and you can take a look at the data, analyze the data, and can then use the data in your business process within your BI tools, for example. So this is a very powerful and strong capability, which is part of the whole data platform. Then the data platform is using a central security and governance layer, so you can implement GDPR requirements or governance rules within this at a single point of truth. So you don't need to contact every database. You have only to implement this security and governance rules within this platform. It's possible to access the data in real time. For example, if you plan to implement a smart city infrastructure, you can use a platform to access the IoT data in real time. It has a lot of query acceleration functionality, so we guarantee to deliver a high performance, the performance necessary to make business decisions in time. And there's also a lot of AEML functionality implemented in this metadata model for these recommendations for automation. And we offer also a Zeppelin notebook to work with a notebook to implement your own AI algorithms based on this metadata model. So a lot of functionality. And last comment from my side to this architecture, we deliver all modern interfaces from a consumer perspective to use this metadata model, which means we support SQL, JDBC, ODBC connectivity. We have an MDX connectivity. We have, of course, web services, SOAP, REST, or OData. We have GraphQL. So a bunch of modern APIs to use this data and to access the data sources via this data platform. So here again, the benefits of a logical data fabric. We call the concept of data fabric based on data virtualization, logical data fabric at Denodo, and so you can easily adapt to new technology, insert new data sources, or migrate, for example, from on-prem to the cloud. You have a lot of more information, single self-service to make better decisions. You don't need to replicate the data, which is from our point very important, to reduce costs, to increase quality and ROI on the systems. You have no data silos, and you have a bunch of functionality to implement governance and security. So this is the topic data fabric based or powered by data virtualization. If we now take a look at data mesh, it's a very new concept proposed by Zhamak Dehghani 3 years ago in 2019, and it moves from a centralized data infrastructure managed by one team to a decentralized infrastructure managed by multiple teams, so-called domains. So the domains are business units which define data products, and this is the big advantage. They have big domain expertise to deliver high quality, high value data products, and they are in charge of managing these data products and to make it available for the whole organization. And a possible architecture of data mesh with data virtualization looks like this. We have on the bottom the different data sources. We have 3 domains defined. We have a customer management domain, we have an event management and an HR domain. And every group defines their own products and exposes products to the rest of the organization. Of course, there is a fine granular role and security system, so that not everybody is able to access all the data, and the data is exposed via this different APIs, SQL, as I told you, REST for web service, GraphQL, for example, OData. So also these data products are available via these interfaces. This is one possible architecture there may be different architectures, also with only one Denodo infrastructure server. So the advantage of a data mesh from our point of view is that you have a lot of expertise in defining the data product. You have multiple teams, so there is no bottleneck, only one team. And the updates and turnarounds are much faster if you're working with more than one team on this data. And so the value of the data products and the quality of the data products due to the domain expertise are much higher and powerful than in another way. So these are the advantages of data mesh. I would like to draw your attention to a workshop we are offering tomorrow at 11 o'clock. We have a 1-hour workshop on data mesh where we put hands-on with Denodo, with the system, and develop data mesh products. It's at 11 o'clock tomorrow. So my last slide is once again a quote of Gartner on data virtualization and logical data fabric. And they pointed out that data virtualization is a powerful foundation for logical data fabric, that it increases quality, governance, and delivers also high, powerful integration and management functions for your data in your organizations. So with this, I'm at the end of my presentation. I'm open for questions. We have a booth downstairs if you need detailed information or you want to take a look at the system in live. I'm happy to meet you there and to discuss further topics of data virtualization, data fabric, or data mesh. Thank you very much for your attention.
Thank you very much for insightful talk. Are there any questions? There's one. One moment. We're coming.
So I like your concept of data virtualization.
Great.
Okay, yeah. Gerald Risto, Software AG. I like your concept of data virtualization. It reminds me of enterprise service bus concept from the middleware. I was wondering, there's a lot of discussion about making the data exchange Gaia-X compatible. Have you ever thought about implementing this in your platform? You heard about this concept, European concept?
Yes, of course. We have discussed this with several domains within the Gaia-X, mobility, automobile, and we offer a lot of functionality Gaia-X is implementing, but they are based on open source, and this is the blocking point for us to proceed in the discussion with the Gaia-X different organizations. But we have a lot of functionality they are implementing to connect to the companies to set up the central data hub and yes, but we don't implement any functionality for Gaia-X. We are agnostic, so we have a framework you can use, but we don't.
Yeah, for me, Gaia-X is shifting from sort of an implementation to sort of an ideas. So I think the ideas could also be implemented not with open source, but with your components.
We have contact to the Gaia-X groups and BMW and all these guys last year. This year we have stopped it then because they said, oh no, open source is mandatory. And yes, we are open. If you have any idea or contact, then I'm happy to talk with them. But we could cover a lot of functionality in the Gaia-X context for the connection to the companies, for the central hub, and yes.
Yeah, because you could do it centrally. That's a big advantage.
And we are scaling. We are more than 20 years in the market, and so it's quite mature solutions.
Okay, thank you.
Welcome.
Are there more questions? That's not the case, and I thank you once again, Mr. Hohmann.
Yeah, thank you very much.